Welcome to Telegeography Explains the Internet, the show that explores the business behind all of the ways humans stay connected around the world. I'm your host, Greg Bryan, and my guest today is Paul Unbehagen, CTO for North America at Nokia. As you will hear, Paul has a deep history in the networking world, so he approaches his role at Nokia from the perspective of many different things in the telecom industry, including being a network engineer. Our main topic in this conversation is enterprise cloud and right-sizing cloud utilization. But we use that as a springboard to really get into many topics about the state of networks in 2023. We touch on the history of the enterprise's move into the cloud and why some companies have reevaluated their cloud strategy in recent years. We frame this in part in the fuel versus friction concept of understanding where to add and where to subtract in an enterprise's cloud strategy based on specific application and compute needs. We touched on, as I often like to, the geography of the cloud and Paul's take on location and design in cloud services. This also brings us to discuss the edge, not only what it means and where it is, but some of the new and exciting use cases of what edge computing can facilitate for enterprises and other customers. Embedded in that conversation, of course, is 5G and how mobile can push the network into being a central part of the business case. Finally, we can't miss bringing up AI ML into the conversation and talk about the impact of artificial intelligence on the network and cloud strategies, both from the flood of bandwidth demand that it promises to bring and the capabilities that can add to the way that we manage networks and DevOps. Paul and I had a great time in this interview getting to pull back a bit and wax philosophical about how networks and cloud have changed and what that could mean for the future. I learned a lot, and I think you will too. Welcome to the show, Paul.
Thanks. Nice to be here.
Excellent. Thanks so much for joining me. So, Paul, I always like to start out the show with the guest introducing themselves. So I figure if you could give us a little bit of background on yourself and then some idea of what you do at Nokia.
Sure. It's a long and winding road.
Yeah.
So background, I would say, is like I've been a member of research and development, working on Ethernet switching, data center, campus, WANs for quite some time. 4 dozen patents in different networking technologies, from MPLS to Ethernet to one of my fun times was actually in the original Fabric discussions. I think people call it the Fabric Wars. It was very friendly, actually, where we were debating SPV versus Trill. We first came up with the term Fabric. As well as that, I've been a PLM leader, developer, CTO of Big Switch as well. I mean, I've been a lot of different places doing a lot of different things all around Ethernet standards. I was an IEEE contributing editor for a while too, as well, as part of the functional work. And IETF member. I've got a few IETF drafts out there. So yeah, it's been a meandering road of fun and excitement in networking.
So definitely able to have you help us pull back and really look at networking from the broad perspective. So that's excellent.
Absolutely.
And then what are you up to these days at Nokia?
Today I am the CTO and engineering leader for the enterprise division for North America for Nokia. Most people probably don't even realize that we have an optical business, larger in size, I think, than Ciena. Then we compete with Juniper. We're like number 1 or 2 in routing and edge. We're in every one of the web scales. You can do Google searches for press releases with us, and all of the contributing work we've done with pretty much every one of the brand names, and as well as lots of the national and global web providers that exist in the world. So we do a lot of work at a lot of different places. So I act as a CTO and engineering lead for a lot of those projects as we're looking throughout North America, and also with the other teams as a whole. So
Gotcha.
Customer function and R&D help and where product goes, stuff like that.
No more indestructible handsets, though, right?
Yeah, no more indestructible handsets. Although if you like that, you're really gonna like our routing because it's well known for being indestructible.
Right,
Pretty much, if
right.
you're using the internet, you're on one of our BGP routers,
Well, it's
right?
Finland is unkind to electronic equipment, I imagine. Right? So the DNA is all there, right? So,
Well, yeah, I think a lot of people also don't know is like we still have Bell Labs, still getting Nobel prizes, right?
hmm
So
hmm
there's a large innovation, division that is the way we kind of look at the world here. We lead on innovation engineering, and how to solve real world problems.
Absolutely, yeah. And so our topic for today, Paul, is broadly around cloud, especially enterprise networks and how that relates to cloud. And so I think it's really interesting to get your perspective from the telecom equipment sort of side, rather than the maybe service provider MSP kind of side, on what you are seeing in that market.
Yeah, I'll probably give an opinion like from a much broader perspective than that, from like the
hmm
history path that we just talked about there is like I think cloud has been a
Exactly.
very interesting term that I've seen evolve in a lot of different ways. And it
hmm
seems like everyone has a very, very strong opinion, and the strength of that opinion usually is in absolutes, right?
Right.
No one seems to actually want to give a little here or there based on the idea that every person's cloud journey is oftentimes very unique in of itself, right? Not
hmm
everybody's going to have the Netflix journey, not everyone's going to have the 37 signals, journey.
Right.
So on either end of that spectrum, what do you do with your view? But I think as I watched everybody from healthcare to manufacturing to, God, you name it, refining, like you could think of like all the industries types as well as the financial types. All of them are trying, I think, go towards a cost savings and really about a simplification, like a running towards ease.
hmm
And I
hmm
think that's kind of like the idea of the line of least resistance, right?
Right.
The belief system is like, and I completely understand this, is that as a developer, you want the easiest way to develop something. You want the tools to be streamlined. You want everything to be, fast and easy to get out of your way to develop the application you need, because ultimately, as a developer, you're measured on the application performance, right?
Right.
And its ability. So a lot of the drive towards cloud was, I think, a lot of this idea that, by doing this, we're going to be able to be faster, more pliable, and we're going to save a ton of money.
hmm
Um,
hmm
and even to throw myself under the bus and my networking brethren, I think there's a large belief in application teams that the networking teams are just too slow as well, right?
Mm-hmm.
And that there might have been some truth to that. Like given the way that we are very conservative, we want to make sure that the highway system we call a network is completely reliable, never falls apart, right? Always 5 nines kind of reliability, or 4 depending on your environment. Doesn't always mash up well when you're an application developer who's trying to get something out fast and do some very, very fast iteration on developer, multiple commits a day, for example, in some of the largest websites.
Well, there's
So
there's a powerful incentive to not get the call at 3 a.m. that APAC is offline, right? So
yeah, yeah, exactly. Yeah, yeah. I've been on that end of the business as well as a customer myself. Right. No one wants to carry. I can actually say I've carried a beeper. Right.
right.
To age myself as working in ops too.
Yeah, yeah,
Yeah.
yeah, absolutely. So the upshot there is that the enterprise cloud journey was driven by this like hope for ease, this hope of lowering some of the friction, if you will, and getting lower costs. How did that work out?
Well, to keep waxing, philosophical here, the it's a similar path as I've noticed a lot of trends in networking, and I don't think we're unique in networking. That is to many other industries, whether it's tech or non-tech. Is you watch this oscillation of the pendulum go back and forth, where it follows the hype curve,
hmm
and so many people ran into it so fast and so heavy, and oftentimes they were pulled into it like a black hole, pulling with the gravity of it as well. And I think a lot of them struggle with the idea of like, okay, how are we going to move it up there? How are we going to move off of the on-prem data? I
Right.
started hearing people start referring to the traditional teams as the legacy teams, having a condescending term to it.
Right.
Um, you know, while everyone's just simply trying to get the job done and move forward, it's a lot of work actually to move the cloud, a lot more than what I think people expected it to be. I
Mm-hmm.
think what really shocked a lot of people were the cost structures of it as well, because
Right.
they weren't, there's a lot of glee when you're running into that pendulum of like all in on something. And I watched this in X25, the front relay. I watched it token ring to Ethernet. We watched it from like all those services into MPLS, or like we were watching it into Fabric. Like every time there's a new wave, everyone bum rushes it basically,
Right. Right.
right? What I thought was the most interesting about this is one of the first times where I've ever had CFOs telling me, in very
Mm.
aggravated voices, was this really worth it? One yelling about it being reminding them of being in the 80s and getting cell phone bills that were numerous pages long that they kept losing and couldn't understand a single line
And it's
of what it meant.
unpredictable in that sense, right? That's when, like,
Absolutely.
yeah, that you're used to with things like compute and network, there being a bill that you
Hmm.
anticipate every month, right? So,
Yeah, you're not used to that strong of a variable cost in
right,
the bottom line, right? You're used to a
right.
very strong static line of cost. Yeah, for sure. And I think
Sorry, go
some
ahead.
things changed. Like as
Mhm.
they were watching these things kind of come in and like move, like it started testing a lot of people's resolve and about what should they move, how should they move. But
Right.
I also think there's a large value in it. Like nobody should run email anymore.
Hmm.
Like
Hmm.
as an example, like polarized functions, like don't run email anymore. But maybe
Right.
some things you should, think about the balancing function of it. Yeah. What were you about to say there?
Yeah, that is really interesting as a concept of thinking through that sort of we were all in on cloud for every possible application, for every kind of compute, every kind of development, but that you're saying it should really be thought through on kind of a use case basis within the enterprise.
Yes, I also think like there's another analogy I like to use is like something I've been kind of bouncing around with a few people over the last few years is and I think we're starting to get there as a whole industry, but the idea that like somehow cloud always became this location, and
Mm.
cloud's not really a location, right? Cloud is
Yes.
a design principle,
Right. Right.
right? And location of it as well is something that's got to be understood here too. So I mean, if we're talking among the brethren of like IT, all the people that exist within our industries, we would understand that, just inherently. But I think a lot of people, we're a very small niche group, and a lot of people don't really in our own industry realize like how small
Hmm.
we actually are of a
Hmm.
community. But there is this natural inclination to imply or incline to think that, oh well, I got cloud. You immediately think of, okay, which cloud provider are you in? Right?
Right.
Oh, where are your servers at? Which colo are you in? Things like that. And it's really a combination of everything together that actually
Hmm.
makes the cloud, right?
Hmm.
Including the application maybe on the mobile device and how it's communicating, and probably is going to start running algorithms as AI starts growing more and more. We push AI directly
Right.
into the device. All of this is going to interact, right, as the new user interface, as
Hmm.
it kind of evolves out of it. And that's going to require us looking at this in a completely different way. And I think that drove a lot of things, I guess you could kind of look at it as like if you're looking at doing taxes once a year, right? Do you want to keep everything in one central location, or do you want to wait for that time when tax season comes and slowly start to distribute down to the neighborhoods, right?
Mm.
The front end systems and then the back end systems and the application systems as well, in a more distributed manner out from central place. But you don't need necessarily keep it there all the time, and
Hmm.
that's nice
Hmm.
flexibility about air quote cloud, right? It's the same thing we watch with 5G. 5G, most people don't really understand unless you're close to the fold here, is that it's actually a cloud application,
Mm-hmm.
right?
What do you mean by that exactly? Yeah.
So 5G is I think one of the most epitome of being a cloud app. It's very much like if you were to take the labels off of cloud architecture from one of the like the major streaming services, or probably any app in every enterprise that's distributed out from one of the cloud providers down. Um, the 5G infrastructure is all still containers. It's Kubernetes. It's
Hmm.
all of the same networking management systems, right? It's all the same compute management systems and storage management systems and the flows. Every bit of it is actually architected. We have cloud developers inside Nokia constantly developing, right? A lot of the applications we call it, they're now applications. What used to be in these massive base stations,
Right.
right? And they're containers. And by
Mm-hmm.
doing that, it's made it far more flexible, right? So you can find yourself like an edge compute, for example, where you have a cloud infrastructure driving down infrastructure for mobile devices, who are then running cloud services on top of that,
Right.
completely transparent, right?
Right.
And that kind of gives us this kind of weird position, as we're both an arms dealer and a superpower at the same time,
Right.
right? Because
Yeah.
the same thing we build to run it, the same networking switches, the same top of rack switches, the same core routers we sell into the major providers are the same ones we use to deploy that 5G cloud. So
Hmm.
it's all the same thing, right?
Very interesting. Yeah, and maybe we'll touch on that a little bit later when we talk more about network geography and the edge. But right now, I want to kind of circle back to the general concept that you were touching on here, which is just enterprise cloud repatriation, right? So having gone all in on the cloud as it was developing a decade or two ago, and now having to make those decisions about what should I keep in the cloud and why should I keep in the cloud. So I just want to get your sort of take first on kind of, from an economics perspective, you might think to yourself, well, the cloud has all these economies of scale that I, as the enterprise, can't really replicate. Why do you think those costs kind of got out of control?
Oh wow, that's another one you could wax philosophically about how to get out of control. Glee
Yeah.
of like purchasing. I think a lot of the assumptions about where costs were, and then the realization of actually how they were structured.
Hmm.
Um, the unawareness of where costs might lie, like what's the most expensive portion of a cloud bill, of a cloud deployment when you until you finally get the bill. Um, there's quite a few like ways you kind of slice that kind of question. In
Hmm.
the driver of it, I mean, we just drove so much into cloud, and you look at like actually like data transitory stuff, storage information, right? I think a great way to take this is actually hear it from the horse's mouth. Go look up David Hannemeyer Hansen's blog post about how his company was able to solve it. Like the guy who invented Ruby on Rails talking about his
Hmm.
startup and how 37 Signals was able to save tremendous amounts of money. I think they went from like $40,000 a month in Amazon bills down to $5,000 a month.
Wow. Yeah.
All right.
Fantastic. Yeah.
Yeah, and that was, I think, if I remember, even X or Twitter, whatever you want to call it, did a 60% savings as well, right? And that's a well
Hmm.
documented one anybody can find about how, because obviously after all the stuff, about what's going on with Twitter and the structure as a business, they wanted to massively reduce their costs.
Right.
But I think they were spending something like $7 million a day,
Yeah, there you go. Yeah, well, and
right?
I should say everyone's familiar with what Twitter is, of course, but 37 Signals was, as I recall, or is, I guess, is a like an as a service kind of product, like what do you call it? Sorry, um, uh,
Yeah, it's a SaaS offering, right?
yeah, it's a
It's a productivity
SaaS offering for
platform.
project management. That's what the word I'm
Yeah,
trying to think of, right? So, like, so you're saying that their sort of like cloud utilization could be streamlined even while serving their customers with their as a service kind of products.
oh, absolutely. Yeah, it's
Mhm.
and they're documented themselves, right? So don't take my word. I'm just giving public information that
Right.
you can easily Google search for, right? It's a very interesting to watch that kind of cognitive dissonance happen because even for me it was a cognitive dissonance of watching like, oh wow, that's a much dramatic difference than I would have imagined. But I think
Hmm.
too, like if we also be careful here about the pendulum swinging back the other way, we're not saying that the idea of like using a cloud provider goes away.
Right.
It's
Of
about like
course.
as the pendulum shifts in each direction, and that binary 1-0, you end up always in every one of these things, somewhere in the middle in the long run, right? Because
Right.
as you pointed out, the economies of scale, but also the economies of scope,
Hmm. Hmm. Hmm.
drag you down like an anchor to the point. Like I heard someone recently point out, like as we're looking at AI networks, for example, never bet against Ethernet. You
Hmm.
just
Yeah,
cannot get past the economies of scale of
it's
it as
been
an
there a
example.
long time,
Yeah,
right? So
like many
it's like
technologies have tried and no one has been able to it's because of the cost structures, right?
right.
And the reliability. Like we've built basically everything you could do in ATM into Ethernet and made it for a cost structure, a hundredth of the price.
Yeah, and even, kind of an aside, but even there, a lot of the cost structures that everyone knows how to work with Ethernet, right? So,
Right. It's
yeah,
ubiquitous. Yep.
yeah,
Yeah, this is one
absolutely.
of those things that's kind of like a fish in water kind of thing. There's that old joke about two fish swimming up to an older one. The older one says to the young ones is like, how's the water today? The next frame shows the two fish go like, what's water?
Yeah, absolutely. I like that
Right.
one. Yeah,
Yeah.
yeah,
So
yeah.
many of us are living in that kind of that sense of okay, what's real and what's the functional thing that I just take for granted.
Right.
And I think that's a fair function of what I was trying to get at earlier with my statement about what is cloud, right? If it's you think
Hmm.
of it as a design principle, it really opens up a whole lot of new possibilities that you don't have to then worry about the economics, right? You can actually start being a little more flexible and modular about things and lower your bills in different ways as some of these examples I mentioned have done.
Yeah, yeah, absolutely. In fact, when we were talking about this topic ahead of time with you and your team, you guys brought up the fuel versus friction concept, and I really liked that as an analogic kind of reasoning here. That you can add fuel and advance that way, or you can reduce friction, right? And I think that's a great metaphor for sort of where the enterprise is in thinking about how do I manage all my workloads and applications in the most efficient way possible.
Yeah, no, I like that analogy. Yeah, one of the members of the team is really great at those idioms. He's great at it. The
Mm,
idea, like providing incentive and things that make life easier, that line least resistance, is a far easier way of getting things done because then you get a lot of more momentum behind it, right? The
right,
more friction you end up in a situation, or another people like a form of that friction would be, for example, technical debt, right?
right.
Or the things that make things hard, or the economics of things, things like that slow you down and make it more difficult to move one way or the other. I think the more mobile and flexible you are, which is the promise of cloud, and when you think of it as more of that design principle, the more fuel you get, the less
Hmm.
friction you have, right? you're able to actually like have your networking move as fast as your application. That's actually one of the things I'm really proud of what we were doing here at Nokia is the reason why we're getting such momentum in a lot of these cloud providers for their infrastructure is because we took everything off the table because we didn't have the baggage of the last 20 years to think about how to run a data center.
Mm-hmm.
And a lot of the things we realized as we were trying to build out things like, for example, 5G being a cloud app is, hey, why do we have to actually look at the switch like a switch just because that's the way we've always looked at it that way? Why don't we look at the switch the same way we look at the server?
Mm-hmm.
And actually make the entire top of rack and middle row and end of row and course all open source, complete access to the kernel, write your own application and use complete DevOps tools on everything in the data center, not just the servers. So the DevOps teams can actually have that same productivity gain, and the networking team can benefit as well, and you can cross feed the productivity and the skills that you learned. Right.
Right. Does that create problems though in terms of the network team in that, the network team is used to thinking of the network in a certain way, and all of a sudden there's new skills, there's new ways of thinking about what the network is for, really?
Not as bad as you would think. I think if we had gone in like similar to what we refer to as like all in one way, then yes, we would have caused those antibodies to kind of to spark up. But because we're all also ourselves old, CLI cowboys, we like our CLIs, but we also like, as a developer, I like being able to program things. So the functional approach allows both a CLI and an API. In fact, they're built off each other. The cool thing too is like if you don't like a command, it's just a couple of Python statements and you've created your own command, or chain a bunch of commands, or you can actually like write an application that has access to kernel. If you want to bring BGP and write your own commands for it, you can do that. So you can have your team use a CLI and you are an API, or a lot of those other like combinations. You can see how like someone who's developer first versus CLI first, right, could use it at the same time in the same box, right? So then you don't end up having those antibodies kind of clash back at you.
Right. Right.
And it's enough migration over time.
And that might even sort of reduce the siloed kind of friction that has been a problem over the years.
Exactly. Yeah. If you got I know many good friends who worked in a lot of like IT departments and enterprises as well as carriers where they're not developers by right, but they can give you the intricate details onto every bit in a TLV for BGP, right, or OSPF or ISIS, right, but that doesn't mean they're going to be like really keen in Python. Well, this is a way that they can actually talk to each other. Like I'm looking at these variables or these particular fields in this show command. Well, that show command happens to have an API call. And that a developer can actually easily pull that up, and we can pull it up into an Knox screen, and they can work together, seamlessly. That kind of approach.
Yeah, absolutely. Before we go on to the next topic, Paul, just one more thing I want to hit on this is a question I often kind of ask at the end of the show, but I think it fits here in this case of given all that you've said, what do you think about the network now as rather than just being this cost that you have to have there as this necessary sort of utility towards being more of something that is driving the applications, that is driving how we think about even what products the enterprise is giving to their customer?
Yeah, this is again a multifaceted one, right? Because you can see this as everything from the mobile connectivity to the wireless, functions like which wireless, for example, to like how the infrastructure is actually done from the data center into the MPLS or WAN core, whatever you're running. I think the thing that a lot of people have often seen networking as simply just being a tag along to make it possible to build these apps. But when you start looking at, for example, the security postures, there are a lot of things that exist naturally now within networking that easily help the security posture for everything you might be doing in your environment. So I've done research, for example, on IoT, a lot of some papers and stuff we did in the past where you got vending machines, you're worried about being rootkitted by, by somebody in North Korea.
Right.
Well, how about we actually lock that thing up in a private VRF in the campus all the way back to the data center so that everything is nice and secure and there's no way that anybody could access that. So even if it is rootkitted, it can't go anywhere, right? There's a lot of analogies you could play in that. But following that thought pattern further is like everything's going to become a service that's driven automatically. And I think we've seen a lot of this from the CI/CD kind of approach too, where commits start driving network changes. So the network is a critical component of it, and it's a flexible component underneath and along with the compute. So it becomes an equal leg of the stool as compute and storage is. Now compute, storage, and network end up having to be all seamless. The more we move into this ML AI world that people, it's actually been around for 7, 8 years. As
Mm-hmm.
most of us actually been working on it, for a while. It's great to see that the whole world is aware of it now, because it brings a whole lot of challenges to make sure that you have very low latent network
Right.
between storage and compute that is highly adaptable and programmable. Right.
Mm-hmm.
Taking a week or even a day to reprogram something is not an idea you can actually carry over into this environment. That's the reason why we kind of threw away a lot of the old world thinking that, why do we have to think of a switch the way we always did? Why not think of it differently? Networking is a first class citizen, I think, in a lot of this,
Mm.
in a lot of different ways. Whether you're talking about the native interface or you're talking even about the tunnel functionality to make it more modular, everything becomes virtualized and everything becomes an API.
Right.
Right?
Right. So that's kind of what's driving the network as code kind of idea that again
Exactly.
I've seen out there the concern that requires a lot of upskilling and whatnot, but also may then reduce friction even if there's some sort of skill friction, if that makes sense.
Sure. Yeah. And given the whole telephony or telecom kind of view of this thing, I think a lot of things, if you kind of step back and look again at a philosophical perspective, is networking helped make voice into an app.
Mm-hmm.
Right?
Yeah.
Apps are now forcing networking to become an API.
Yeah. There you go. Yeah. Yeah, that is really funny. That's a good way to put it. All right, so Paul, I also want to talk because this is telegeography, right? So we always love thinking about how geography impacts all of this, and I think that's particularly salient in cloud in some respects. So
Mm.
our general research sort of is based on the idea that where you are matters, right? So do you think that that enterprises in particular need to think about where their data centers are located and where their cloud on ramps are, and how the cloud workloads are being distributed, rather than just, hey, I get my stuff on the cloud and I don't have to think about that anymore?
Yeah, absolutely. There's without a doubt that quickly plays out not only from a financial perspective, but even just a functional use of the app, right? Its
Right.
performance, regulatory reasons. I mean, there's a plethora of reasons why you need to be considerate of your location and everything you look at here. I like thinking about the original statement I made a little while ago about cloud's not a location, it's a
Right.
design principle,
Mm-hmm.
right? In that very concept there, we do a lot of work with national cloud providers, like in country, around the world, but even within region, within neighborhood. We have hospitals that have to use local colos to get access to, say, a major cloud provider, like to hop onto Azure, for example.
Mm-hmm.
But because of regulatory reasons, that data is not going up in Azure. Just some of the compute, maybe the AIs from Azure is working on data that's co-located right there next to the hospital, right?
Mm-hmm.
Or if we're working with internet exchanges too, like those locations in individual national entities or cities, wherever they happen to be, is a critical component of it. I think too, as we look at what is it like, our interface to cloud is
Mm-hmm.
in our hands, right? And if
Mm-hmm.
Apple gets its way, it's going to be on our eyes,
Right.
right?
Yeah. Yeah.
And that's a critical point of that. Like the responsiveness of that user interface is all about the location where it is. If you've got to travel, like anybody who's been in networking more than a day knows what it's like to try and get access to information. That's the other side of the planet, and you wait there for the latency,
Yeah.
spiral,
Mm-hmm.
right? That little
Mm-hmm.
bubble if you're on a Mac, that little spinning wheel.
Spinning wheel of death. Yeah.
Yeah,
Definitely.
exactly. Right. But that's a natural reaction. You kind of look at it as a customer of Starlink myself. It's kind of funny watching as they improve the latency in the in Starlink
Mm-hmm.
compared to being on a mobile, right? You definitely notice the latency aspects of it in the early days. Now they've solved a lot of those problems. They're doing great. But looking at like my Verizon phone or my AT&T iPad, I never had those problems, right?
Right.
Getting same similar speeds. That location function, it definitely affected the way that I perceived, to even video or calls like this.
Mm-hmm.
MOS scores, if you're familiar with that old concept, right?
Mm-hmm. Yeah, well, it's interesting that you bring up Starlink, is that in their case, it's a very infrastructure oriented change, right? They just got more birds in the air, right? So,
Exactly.
you know,
Yes.
yeah,
Add more
uh,
capacity. Yeah.
yeah, exactly. But it's a similar point then with 5G, that I'm not a wireless guy, but as I've always understood it, that's one of the issues with 5G, of course, is that it's got a much smaller radius around each tower, and it has poor penetration, so you could even turn your head and lose the signal. So the operators have had to think about, okay, there's all these cool promises of what we can do with 5G, but ultimately you have to have a totally different tower density. You have to have a mesh network instead of a connection to a single tower and that kind of thing.
Yeah. But then even economies of scale kind of play in your favor there, is because as you need more, more antennas, and you need to think about them differently, you end up deploying more, which improves your economies of scale in it. But it's also a big piece of the like, why is it a cloud application? Because you had to be more modular and flexible to drive down the cost structures of it. By comparison, I will tell you, like from the latency and the bandwidth perspective, sitting here in Denver, Colorado, in USA, I'm getting near 2 gig a second on my iPad, right, downtown on 5G. So, and I'm more than 10 floors above in the air, right? It's a great kind of capacity and great speed. That low latency aspect of it, as well as it's great for when we're talking about IoT devices sitting out there in the middle of the the city collecting data as well, sitting on that, whether it's public or private. That's another boom we've watched, as well as the private wireless functions on that, as people trying to drive out augmented reality, which has been something we've actually been working on for quite some time with like glasses and other environments with Microsoft and a few other providers. It's really cool to watch how that is all one seamless network. Without a network in between those goggles and a knock, for example, they don't really provide much functionality.
Right, and you're saying that also that something like that latency is absolutely critical to its functionality, right?
Absolutely critical. Yeah, if that punchline didn't come across, if they were bringing that out, latency absolutely matters when you're trying to look at a HUD and a screen that's on your eyes. Right.
Exactly.
Absolutely matters. Right.
Yeah. Which I think raises a point that I wanted to talk about, I think in greater detail anyway, which is, we've been talking about sort of the general concept of going all in on the cloud and then cloud repatriation. But then there's also the sort of decentralization of the cloud, right? So already we had this complication of sort of what to put in the cloud and how to do that. But then there's the complication of not just where to meet my cloud providers and where is my data stored, but then pushing things out to the edge, what to push out to the edge and what the edge is. So let's start breaking that down. Like first, maybe let's get your take on kind of when you want to talk about edge, what does that mean?
Okay, so edge means a lot of different things to a lot of different people. So let's kind of break. I like your pointer there about breaking it down. So if I take that same latency statement we just made a second ago, I would have exactly the same statement in the data center as I do for the user sitting at the other end of the edge, right?
Right.
So if you imagine the network is like some constrained circles, moving out like a target, with the bullseye in the center, is like the edge is that entire radius on the outside from whether it's the servers connected on one side to the users. Now, edge in a wireless context, as you've probably heard, is the MEC, originally called the mobile, edge. So now it's the multi-axis edge, right? And that transition in those terms really came about, I think, was the ETSI standard, right? That kind of called out the point is like edge is far more than simply just the device in your hand, right? Like we hinted at it with the goggles, but it's far more than that. Is like it's the IoT stuff out there that's connecting on these networks. Edge as well, getting the compute, and this is why you'll see companies like Red Hat and HP and others who are very involved in this standardization as well, is that it's about getting that compute really close to those end devices, so you can make actionable statements and compute directly on that data, process it, and get it to the users that might be in different places inside your organization, right, in real time. And real time being the real term, real time, right? Not some kind of lag of 10 seconds or or more, because you have low latency. You're trying to measure it in a millisecond kind of run. Kind of thing.
Yeah. So not having to go all the way back to what we think of as a proper data center, if you will, even if that's relatively close, but sort of MEC is all about putting that at the mobile node, maybe at the tower, maybe in some other locations.
Right, exactly. If you look at the future of like solar farms, wind farms, for energy, for example, as they're doing a lot of work in that, if you're looking at like refineries and things like that, there needs to be compute acting live on that information about what's the maintenance. This isn't even new. I think there are several rail companies that are big brand names here in the United States, for example, have been using sensors right there on tracks to actually with microphones listening to rail cars go by, right? And by the sound of the wheel, they can predict within 2 weeks of when it needs maintenance.
Wow, that is fascinating. That's exactly what I'm always interested in hearing about is the sort of like, okay, that sounds really cool, in terms of the networking, Greg. What can I do with this? How does that enable me to be a better enterprise in whatever respect that means, right? So,
Right. Yeah. Can you imagine the amount of like productivity gains they gain on that, and
right.
the reduction in maintenance costs because now there's not a wheel falling off in flight. They actually pull the car off within a week or two of it needing its maintenance. Right. If it's not within scheduled times. The idea, like as well, I think one of those well-documented stories is the drones. So, for example, here in Colorado, we have a lot of rail bridges, right, that go across very large chasms. And in the past, there used to be guys on and rappel ropes going down to look at the bridge to make sure it's safe. Now a
Right.
drone flies down, taking 4K video, and AI is going over the video to see what structural problems might need to be dealt with and at what time frame.
Right.
Right? That's all done with an on-prem cloud
Right.
in these environments.
Mm-hmm.
All right. So it's a really, really great point you made. There's like, what can I do with this? Because you're not doing it for the sake of doing it. You're doing
Right.
it for some kind of like fuel, and the fuel versus fiction,
Right.
function there.
Yeah.
That is a massive productivity gain, and to the point of the economics of this thing, right?
Yeah, yeah, and gets exactly to that point I wanted to raise before, where all of a sudden, rather than just, hey, this is our business model and we need to throw a network under it, it's what can we change about our business model enabled by these changes in the network.
Mm-hmm.
Yeah, absolutely. So let's talk then about AI. You've touched on it earlier, but I wanted to get in a little more depth. As you say, it's actually been around a long time. It's now kind of hitting a critical point, I think, where adoption is maybe on that scale of hype right now, right?
Mm.
I've heard a lot of folks on the carrier side talk about this primarily in terms of the flood of bandwidth demand that's going to come with it. What's your take on kind of the impact of things like Gen I and ML on the network itself?
Well, okay. So my personal take on this thing is actually I'm kind of excited to see the ways in which we'll use it, and I think here in Denver we had supercomputing this week, so that's a bit why AI is a bit on the top of mind, right? And
Oh,
obviously
yeah.
that was a big part of that kind of conference.
Mm-hmm.
And the statement I've heard recently, thrown around is the idea is like, instead of thinking about it as artificial intelligence, think about it as augmented intelligence.
Mm-hmm.
Like imagine a day when you're visiting your doctor and there's AI working with him, so he doesn't have to know every esoteric disease that might exist out there,
Right.
but is working with the set of variables from your blood tests, your DNA, and a bunch of other things to customize medicine directly for you with this endless compute function behind him,
Right.
right? As his Watson to his Sherlock.
Mm-hmm.
Okay.
Mm-hmm.
If you take that idea of augmented intelligence and you apply it to the idea of every other space that exists out there, we gave a couple examples there when we talked about rail cars or drones with 4K and AI footage. We have actually a project here. We actually have a drone project where we sell to companies and governments around the world, right? Where the drone is flown by AI.
Mm-hmm.
That's done right now and it has been for several years, right?
Yeah.
And of course, what is it that thing's connecting with? Doesn't have a wire to it. It has a low latency, right?
Right.
5G connection, up to it, and there's a data edge compute that's running the AI to fly the drone.
Mm-hmm.
Now, like moving into like what's near and dear to my heart, inside the data center, we took a different approach to like what could AI mean to us, and I mentioned earlier how we decided to take a new approach to the operating system on these switches, right?
Right.
Well, if we're saying it's API driven, well, that means AI can drive the entire switch.
Right. Mm-hmm.
Right. And so we actually wrote a ChatGPT interface directly into the CLI.
Mm-hmm.
Right. So while everything you said a second ago about the growth in bandwidth and the growth in functions, I'm going to give you an example of like how this actually plays out in a lot of different layers. There will be AI on top of AI on top of AI in a lot of different directions.
Right.
So if you're sitting on a switch and you're not quite familiar with what a VRF is, for example, you can actually ask it within the context you're in. Say you're in BGP, like, help me configure a VRF instance, or I need to do a new IP service. Just you don't even have to know what a VRF is,
right?
Or because it's been fed with all the documentation that exists, right, for Nokia's routers and routing and concepts and services as a concepts too, it can respond and talk to you as an intern would, and it will go do what you tell it to do and actually tell you what it's doing. Or if you're like want to know what's live in your network, you can start having a conversation with it about how are the interfaces, are we dropping packets, right? Now you can imagine this at a network level too, when you start having appliances that are actually looking across the entire network and watching and acting as your augmented intelligence within the environment. So you never have to worry about getting a text email. Like, what's the one thing that we all know when a network goes down or a switch goes down? So you want to get all of this like dev information right off the router as fast as possible.
Right.
Well, if you have AI looking at this thing, there's a potential we can end up where it's doing that all automatically and live feeding things, or even predicting when. Imagine that rail car analogy where a wheel's going out. Well, what if we were able to start, predicting when an SFP or a CPU or a memory might have an issue, right? Or that the whole like solar flare concept I used to laugh at, but it actually was a real thing back when we were at MCI WorldCom, where solar flares would mess with, obviously routing tables and memory, right? It was a well-known thing there. There's a lot of ways you could play around this. So you think about that within the network, how you use it as, like, we call it AI ops, by the way. So like DevOps, but it's AI ops, right? It's an extension of that. Now, imagine you've got like researchers out in the field in agriculture. You've got in mining functions, you got people doing that as well, saying, what's going on here? A geologist might be working in the field. All of that means the AI is as close to the user as possible, and where AI is, again, like augmented intelligence, is that new user interface. It needs a strong compute right there with you. And it's going to require a hell of a lot more bandwidth to get back, and a low latency bandwidth. Now, what is also interesting is that it also means that the data center that these switches and these servers are connected to, most data centers, most people realize, are still running very old switches.
Right. Yeah, absolutely.
Right. That's not necessarily what needs to be there to actually support when you start taking the test and the training data into a live deployment. All of that has to be, like, as I pointed before, is that the three legs of that stool: storage, compute, and the network. Because you need to have a very fat pipe that's very low latency between storage and the compute itself, and then back out to the user.
And you don't want the switches to be the bottleneck in that equation, essentially.
Exactly.
Yeah, that's fascinating. Yeah, I like to think of it kind of as, since most of us have had this experience of being in a car that has some amount of self-driving capability. None of us, despite many promises we've heard over the past few years, have a car that will actually drive itself, but you're assisted in it, right? And so you might have, you don't have to regulate your speed yourself anymore, and you won't be able to veer into the other lane, as it'll take over if you do that sort of thing. We kind of think of folks driving networks as kind of handing more and more of the need to drive the network off, in a certain sense, right?
Yeah, absolutely. I like that analogy.
Yeah. But, and then, like you said, and then in addition to that, handling the massive amount of bandwidth that all of these applications for other people are going to take. But that's facilitated, right, by this idea of having the network engineers be able to pass these things on. Just while we're on that, then, what's your take, Paul? Again, this is probably mostly your sort of personal thought on it, but on the whole network as a service world. So do you see that as being driven by this as well, the need for maybe, bandwidth on demand, the need for enterprises to have the underlying network consumed in a different way, more like cloud?
Oh, yeah, I think that's a natural evolution of this, is that genie's well out of the bottle, right? And that's going to become just a natural function of breathing in this environment. That's the water to the fish here, if you will. Like, to keep driving all these analogies, right?
Those analogies are so useful for these topics, I think. So,
yeah, absolutely. Yeah, the idea is showing up, and you don't have the ability to rapidly, and I mean the idea of like calling a method call in a code, right, in Python or something like that, right, in a CI/CD function. If you don't have the ability to actually just drive the network there, it is a radical change that we're seeing. If you don't have it, it's just going to slow down to a molasses, right, what the application developers need, right? And that's just something that's just standard. It's just, you have to take it. It's like trying to say you can buy a house without plumbing. Right. Network as a service is now the way you do it, right? And we use CLI as human beings to kind of poke around like a mechanic under the hood. Right.
Yeah, absolutely. That makes sense. All right, so Paul, this has been really fascinating. You have an incredible breadth of knowledge here. So I've been trying to keep up, and I'm sure everybody else has. But I just want to close out kind of with one more question that's we touched on before, but I'd like to get the really sort of philosophical take here. Is that, with your deep experience in this world, including like MPLS and the WAN world, I always like to get my guest take when this topic comes up on what does it mean to even have a WAN anymore in this world where we're just connecting to edge? It's just connecting to particular applications cloud. Is there a network anymore in the way that we used to think of it as this kind of moat and castle kind of concept, or is it just more sort of networking is about applications and compute and development?
Oh, I love that question, the way you framed it, right? Because you're calling the question the references in which you look at the world. Um, I think you kind of nailed a point that I made in the beginning of the call, and you might have done that by design and a very well done job. Applications are the whole point networks exist.
Hmm.
The idea that you still have castle and moat is no longer a way in which you can actually see the world. Like the point in which we build these data centers and these WANs is to serve applications to make human beings productive,
Right.
right? Or in this case, maybe at the point is like applications are talking to other applications, like IoT streaming data back into a database, and something's trying to like pull over that data lake. But the point is, you're trying to make things far more productive. And there's been so many promises over the years. And one of my degrees is business with a focus on Mac economics too. So I
Mhm.
tend to look at the world very twisted,
Yeah.
right?
Yeah.
It's like productivity per person. There's all these kind of metrics out there. But
Right.
at the end of the day, if you're not making your life easier, and that's all that really, all those little acronyms economists
Yeah.
use is it's it's a function of is like how do human beings deal with strife and struggle and scarce resources.
Hmm. Hmm.
So yes, WAN and your perspective of WAN is no longer just that core router and what it's doing across the country.
Right.
It's what is it doing to help the end user at the end of the day, right? Including that campus switch, that data center switch, that core switch that's doing like as we're working on 800 gig interfaces, we're deploying those, and we're getting in the soon here into the multi-terabit kind of interfaces, and those will be coming soon. Just as an actual expression, why are we working on those? Why is there still strong demand to move from like how long ago we were just simply talking about going from 40 gig to 100 gig? Now
Right.
we're talking about 800 gig to 1.6 terabit and things like that,
Yeah.
right?
Yeah.
Well, something's driving that, right?
Hmm.
And it's all around us, and I don't see it slowing down. I think one of the best analogies I saw in this too, by the way, it's going to drive that home even more, is if you look at the idea of compounding. Here's where
Hmm.
my worlds kind of collide.
Right.
My economist and my computer scientist background. So compounding is the idea of like doubling, 1 to 2, 2 to 4, 4 to 8, 8 to 16, right? And you look at this, incredible graph of like a hockey stick going up, right?
Hmm.
Kind of doubling. Well, look at Moore's law. Moore's law is the law
Yeah.
of doubling,
Yeah.
right?
Absolutely.
From a technology perspective, right? We're on, I think, like chess piece, 32. And if you're looking at the old story, like where the compounding came from, it's like a chessboard. Like you start on piece on place box one and you double to 2 to 4, and by the time you get to 32, you're in I think you're in the hundreds of millions, but by the time you go from 32 to 33, you're in the billions.
Right.
All
Exactly.
right.
Yeah.
And then when you're in your 40s, you're in the quadrillions, that
Hmm.
kind of thing. That continues to say like how you perceive the world in a simplified world of WAN, campus, data
Right.
center, right,
Right.
is going to
Yeah.
go away so radically fast, right, that it's
Hmm.
going to blow by you, like the Flash in some kind of Marvel comic, right, kind of thing.
Yeah, that I love that. That's a great way to put it, and I think especially worth and thinking about exactly the perspective that you brought here that I don't often get, which is that means that the switches themselves, right? That the whole network has to be constantly replacing to match this hockey stick graph, as you say, right? So
Exactly. Yeah.
yeah,
And you're not going to do that by continuing to think about the world you got today, where you need to go tomorrow, by carrying forward everything you did in the past.
right. Right, exactly. That this is too rapid of a change in the world, so
Hmm.
almost the singularity of the network, right? So,
Absolutely. Yeah.
yeah, yeah. Excellent. Well, Paul, this was a fascinating conversation. I'm going to enjoy going back and picking all of this out because you brought so much information. So thanks so much for joining me. How can listeners keep up with you and your work at Nokia?
Well, I'll admit that lately I have not been as active on social media as I should be. Mostly
I
because my
know
hands.
that struggle well. I do
Yeah.
a podcast, so yeah, yeah.
Okay, so then I don't feel so bad. But yeah, you can follow me on X at Unbehagen, LinkedIn as Paul Unbehagen. Just look for Nokia Paul Unbehagen. You could also follow. Usually find me through like the Nokia handle or the Nokia Industries handle on all social medias as well.
Excellent. All right. Well, yeah. Thanks so much for joining, Paul. And yeah, let's keep in touch and see how all of this develops.
Absolutely. It's a great pleasure. Thanks for having me on today.
All right. Cheers.
Cheers.
Thanks for listening. Telegeography Explains the Internet comes from the experts here at Telegeography. It's edited and produced by Jane Miller, and it's hosted by me, Greg Bryan. And I also wrote that theme song you're listening to right now. To learn more about our data, jump over to telegeography.com, and we'll see you on the internet.